Welcome back to another exciting math video. Today we're going to be talking about how to solve two-step equations, where yesterday we solved one step, today we're adding on an additional step, but all that additional step means is we're adding another operation. So where we just did one operation with one step, now we're having two operations, and we'll talk about what that means in just a second. Our learning target is to solve one and two-step linear equations with one variable or one letter, and then to solve practical problems requiring the solution of one or two-step equations. How are two-step equations different from one-step equations? Very simple, I just said it. One-step equations have one operation, and two-step equations have two operations. And when I say operations, I mean adding, subtracting, multiplying, and dividing. With two-step, it's either going to be adding or subtracting with multiplying or dividing. So you're never going to see a addition and a subtraction together. You're going to see just one or the other. All right, if you break out your notes, we're on page 13 of your notes that I gave you today in class. Go ahead and write down this information. It's critical that you're taking notes so that you have these to go back on when you need them later on. For two-step equations, when you're solving a two-step equation, you need to move the constant, which is that number by itself, away from the side with the variable. Basically, that means that we're going to add or subtract first, and then multiply or divide. That's all a two-step equation is. So if you look at these examples, our example number one, we have 4x minus 9 equals 21. So if you look here, this first part, 4 times x, is the multiplication. Then I'm subtracting 9, so that's where you get your two steps. Here's 1, here's 2. However, when we solve them, if you remember what I said, we're going to add or subtract first. So if you look at this example, we're not actually going to solve this, but I just want you to point out what is the constant, or the number that's constantly alone, that is going to be undone or moved first. So, of course, we always want to divide our equation into two pieces. We're going to look on the side with the variable. So I'm going to highlight that. Well, maybe. So here's my side with the variable, and I'm looking for the number that's not with the variable or with the letter, and that is this negative 9 or minus 9. So to undo that, how would I do that? What's being done is subtracting 9. So to undo it, I would add 9. You don't have to write that, but it helps if you see that. Again, look at number 2. We're going to start on the side with the letter, which is this side over here. And I want you to think what's being, what's being done, and how do I undo it? So if we look here, I have a 4 minus 5r. That minus 5r goes together, so what's the other piece is a positive 4. So we're adding 4. And then how do I undo that? Is I subtract 4. I say we're adding 4, but really this is just a positive 4. So that's why it's adding 4, not subtracting 4, even though the operation being done is subtraction. All right, on this one, our variables on the right side instead of the left side. So we're going to look, we have two pieces, we have two terms. We have that first term which is 2w, and then we have plus 17. So what's being done is I'm adding 17. So how do I undo that or move that constant? I'm going to do the opposite, which is to subtract 17. If you have a chance and you want to write this down, this is going to help you so that moving forward we know what we're doing. Okay, if we look down, now we're going to do some solving examples. I'm always just going to divide the equation in half. So I've got a left side and a right side. I'm going to start on the side with the variable. Remember, I want to do addition or subtraction first before I multiply or divide. So first I want you to think what's being done, and then what are we going to do to undo it. So let's start at the variable first. We're multiplying by a -2. So how would I undo a multiplication by -2? I would divide by -2. And then what else is being done? I have a +5. So how do I undo a +5? I subtract 5. So here's what's being done to the variable. Now let's move over to this side, and we're going to move this way to undo it. So we're going to subtract 5 from both sides first. 5 minus 5 is 0. Then we have a -2n. And over here we have a -1 and a -5. So if you think of your battle boxes, I would have my 1 and my 5 both in the negative box, which means I just combine them. So I would get -6. You don't have to write all that. If you have a calculator at home, you're welcome to use a calculator. I'm also going to erase this 0 because I don't need it. So now I look back, and what's being done? I took care of these. So now I have to divide by -2. So to divide by -2, we draw this fraction bar. Then we divide by -2, divide by -2. The 2's cancel out because -2 over -2 is just 1. So I'm left with n. And I have -6 divided by -2. A negative divided by a negative. Remember your integer guy. If we have a negative divided by a negative, all that's left is a positive. 6 divided by 2 is 3. So my answer is n equals 3. So let's check that, and we're going to check it just like we checked it before. Rewrite your problem that you had, but in place of n, I'm going to put parentheses and see if it works out. Now I'm going to take this 3 and plug it in here. Now I have to follow order of operations, so I'm going to multiply first. I have 5, and then I have -2 times 3, which gives me a -6. If I have 5 minus 6, again, think of your battle boxes. I have a +5 and a -6. There's more in the 6, so my answer is going to be negative. How much more? 6 minus 5 equals 1. Did I get the right answer? I got -1 equals -1. Is that a true statement? It sure is. So that means 3 is the correct answer. Let's look at our next problem. Again, first step, just divide that equation into 2 parts. I'm going to think what's being done, and what do I need to undo with the variable. So first thing that's being done is I'm multiplying by 3. Then I'm adding 1. And that's on the side with the variable right here. To undo +1, I'm going to subtract 1. So let's subtract 1 from both sides. Bloop. 1 minus 1 is 0. Do I need to write that? No. I just want to remind you that it is 0. So now these cancel, and I'm left with just 3x. 7 minus 1 is 6. My next step is to undo this multiplying by 3 by dividing by 3. That's the inverse operation. So I'm going to divide both sides by 3. 3 divided by 3 is just 1x. 6 divided by 3 is 2. So now I got my solution is x is now 2. Let's check it and see if we're right. 3, and in place of x, I'm going to put my parentheses, plus 1 equals 7. Now I'm going to see my answer. I said x was 2, so let's plug it in and see what we get. 3 times 2 is 6, plus 1 equals 7. 7 equals 7, that's a true statement, so I know my answer is correct. So basically with two-step operations, we're always going to add or subtract first, then multiply or divide. And you're simply looking at what's being done and then doing the opposite operation of what's being done. Let's look at number 3. Start on the side with the variable. I'm going to divide my equation in half. Let's look at what's being done and undone. How do I undo it? What's being done to the variable? First, I'm multiplying by negative 3, and I have a positive 6. So to undo that, I'm going to take positive 6 and make it a negative 6, or subtract 6. So let's do that on both sides. 6 minus 6 is 0, so I know those cancel out. I'm left with just negative 3x. And I have 21 minus 6, which if I plug it in my calculator, I know is 15. Now I have to look at this step. I'm multiplying. The inverse of multiplying is dividing, and I have to keep it a negative 3 so that my answer, my x, will be positive. So I'm going to divide by negative 3 here. Whatever I do to one side, I got to do to the other. So now I have negative 3 divided by negative 3, which gives me a positive x, or positive 1x. Those cancel. Now I have 15 divided by 3. That is 5, but I have to remember my integer man. Integer Bob says if I have a positive and a negative, my answer is negative. So don't forget your integer rules. I saw that on a lot of the quizzes. You have access to a calculator. If you can't remember your integer rules, please use your calculator so you don't forget. So my solution is that x is now negative 5. So to check it, I take my old equation, the one I started with. I'm going to plug in my answer. So I said x equals negative 5. And now I have to use my order of operations, which says I multiply first. Negative 3 times a negative 5 gives me a positive 15, because negative times a negative gives me a positive. So 6 plus 15 is 21. Does 21 equal 21? It does. That's a true statement. All right, look at number 4. Number 4 looks a little bit tricky. I don't want you to get upset or get worried. All we have to do, our first step, is to get rid of our double signs. If we have a negative and a negative, cross those out, we're left with a positive. So now I have m plus 8.2 equals 15.7. That's simply a one-step equation. Divide your equation. What's being done is I'm adding 8.2. So to undo that, I'm going to subtract 8.2 from both sides. When I subtract 8.2 from 8.2, I get just m, because that equals 0. And now I have m plus 0, which is just m. And then I have 15.7 minus 8.2. 7 minus 2 is 5. Bring down your decimal point. 15 minus 8 is 7. So my solution says that it's 7.5. Now let me check my answer. If I go back to my original, whoops, what did I forget to do? I forgot to replace my m with my answer. My answer was 7.5. So now, if I change these, they still are going to change to a plus. So now I have 7.5 plus 8.2 equals 15.7. Does it equal 15.7? Start on the right. 5 plus 2 is 7. Bring down your decimal point. 7 plus 8 is 15. Did I get the right answer? I sure did. So I know my answer is correct. Okay. We're going to go through these. We're going to skip number 5 because I don't want to do too many and make this video too long. But I do want to go to number 6 because it looks different. We have a fraction here, but that's okay. We have the multiplicative inverse, so we know how to get rid of that. So let's divide our equation. We're going to start on this side where my y is. What's being done? And how do I undo that? So first, we're multiplying by 1/3, and then we're adding 5. So now I have to undo that. The first step is to divide, or I'm sorry, not divide, but subtract 5. So let's subtract 5 from both sides. 5 minus 5 leaves me with just 1/3 y. 6 minus 5 is just 1. Now, to undo that times 1/3, we're going to multiply. Remember, if we have 1/3, we can multiply by the reciprocal to get just 1. That means I take this and I flip it around. So I'm going to multiply by 3/1, which is the same thing as multiplying by 3. So let's multiply by 3/1, or just 3. 3 times 3 is 3. 1 times 3 is 3. So I'm left with just 1y. And then I have 1 times 3 is 3. 1 times 1 is 1. What is 3/1? It's just 3. So my answer is y equals 3. So let's check out and see if that works. 1/3 times 3 plus 5, does it give you 6? We follow order of operations. 1/3 times 3/1 gives you 3/3, which is the same thing as 1, plus 5 equals 6. 1 plus 5 is 6. 6 equals 6. And my answer is correct. Let's flip over to the back side of the notes. We're not going to work all of these. We're just going to work number 5, number 6, and number 7. And then the rest of them, 1 through 4, you'll do in your Edmodo quiz, and number 8 you'll do in your Edmodo quiz. So we're going to skip these because you're going to solve them for your Edmodo quiz. And we're going to jump down to number 5 because it looks just like the one we just solved. Start by dividing your equation in half. What's being done? I am dividing by 4, and I'm adding 10. So how do I undo that? Let's go this way. To undo the positive 10, we have to have a negative 10, or subtract 10. So let's subtract 10 from both sides. 10 minus 10 is 0, so I'm just left with x divided by 4. And on this side I have 34 minus 10, which is 24. Now, to undo dividing by 4, I'm going to multiply by 4. So to show multiplication, we use the parentheses notation, which means multiplication. I'm multiplying by 4 on both sides. This cancels because I end up with 4 over 4, which is the same thing as 1. So x equals, and then I have 24 times 4. And if you plug it into your calculator or multiply it by hand, you get 96. Now, this doesn't have the check step, so I still want you guys to follow that check step so I can plug things back in to see if it works. I have 96 divided by 4 plus 10 should give me 34. 96 divided by 4 is 24. And if I add that to 10, 24 plus 10 is 34. So I got the correct answer. So that's all we're doing. Now, number 6 and number 7 are special cases, along with number 8, but number 8 you're going to do on your own for your Edmodo quiz. So if you look at this, this says x plus 12 is all of that. The sum of that is being divided by 6. So in order to do this one, normally we do the addition or subtraction first, but because I have to find what the sum of this is before I can divide, I have to undo that division first. So what's being done and what do I need to do? Undo it. So first I'm adding 12, and then once I add 12 to x, I'm dividing by -6, and don't drop your negatives there. So to solve it, we have to undo that division. So we're going to multiply by -6. So let's multiply each side by -6. I can't write it next to because of the 6 that's there, so just know that that's -6 times -14. When I multiply, these 6's are going to cancel out, so I'm left with just x plus 12. And then on this side, I have 14 times 6, which is going to give me 84. And it's a negative times a negative, which gives me a positive. So then my next step is to undo the addition with subtracting 12. So I'm going to subtract 12 from both sides. I'm left with just x on this side. 84 minus 12 gives me 72. So now let's plug it back in and see whether or not that is correct. So we have -14. Sorry, this is my check step. If you want to, you can divide this so it's equals 72 plus 12 divided by -6. So in this situation, I can't divide first, so I have to add. That's why we went backwards before. 72 plus 12 gives me 84. And I'm going to divide that by -6. 84 divided by -6 gives me -14. Does -14 equal -14? It sure does. So when you have an addition or subtraction problem on top of the division bar, that has to come last. So that's the difference between this problem where the division is being done just to the x and this problem where the division is being done to the sum of x and another number. So there's a difference. If you see this one, the first one, number 5, we're going to undo the addition first, but on the second one, on this example here, we're going to undo the division first because we have to keep that x and the 12 plus 12 together. Okay, last example we're going to do together, and then we're going to be done. So this one's just like the one we just did. If you can see, we have a problem on the top here that's being divided by 3. So when we go to say, oops, what's being done? So first, we are subtracting 3 from r, and then we're dividing by 3. So if we go this way, to undo it, we are going to multiply by 3 first. So let's multiply this side by 3 and multiply this side by 3. I can't write it down here next to it, so we're going to know that those 3's cancel. I'm left with r minus 3. 5 times 3 is 15. So then my next step says I'm going to undo this minus 3 by adding 3 to both sides. Plus 3, plus 3. Bloop, bloop, bloop. The 3's here on the left side cancel, and I'm left with just r. 15 plus 3 is 18. So my solution that I got says that r should be 18. So now let's plug in our answers and see for our check step. So we said that r minus 3 divided by 3 should give me 5. And I said that r is 18. So again, we have to go 18 minus 3 first, which gives me 15 divided by 3. Does that give me 5? Sure does. 15 divided by 3 is 5, so 5 equals 5. All right, you're going to solve number 8, 1, 2, 3, and 4 on the Edmodo quiz. So make sure you have your notes handy. Go ahead and solve them before you log into Edmodo. That way you're not running out of time. And make sure you're checking your answers. So there should be plenty of room to check your answer on the right and work your problem on the left. Good luck, and I hope everybody completes their homework.